In this video, I'll be going over the solutions to the Friday, February 6th AP Pre-Calc quiz. So this is the quiz here. You can find this quiz and the solutions in the description of the video. So the first question says to solve the tangent of what angles will output negative square root of 3. So we should be familiar with the angles that have a slope. I say slope because tangent of the angles represent the slopes. So I'm going to draw angles in the second quadrant and fourth quadrant that have a slope of negative square root of 3. Now it says solve for x, so there's an infinite number of solutions to this equation here. So our solutions are x equals, the angle in the second quadrant is 2 pi over 3. So the tangent of 2 pi over 3 is equal to negative rad 3. Now we're going to add from this blue angle here to the red one is pi. From red to blue is plus pi again. Keep adding pi. Or I could take away pi and get from one angle to the other one. So we're going to put plus pi k, where k is an element of the set of integers. So that's our solution for 1a. 1b. Again, it says solve sine of what angles output a half. So when we see the trig function sine of angles, we think about the y coordinates on the unit circle. So y coordinates of a half, there's a point right here, and there's a point right over here with the y coordinate of a half. So with tangent of x, in part A, the relationship between the blue to the red angle, we can keep adding or subtracting pi to get from one angle to the other one. Here, if I go from the pi or this blue angle over here, it's not going to be pi apart. I'm not going to be revolving pi. It's a smaller angle here and then a bigger one there. So I'm going to write two separate equations. So for part B, we have x over 3 equals the angle in blue is pi over 6 plus 2 pi k. That represents going around, adding 2 pi, and getting more and more solutions, or we could take away 2 pi. If k is negative 1, we'll be going clockwise 2 pi. Now we also have x over 3 equals the angle in the second quadrant. We can write that as 5 pi over 6 plus 2 pi k. And again, k has to be an integer. So the sine of 5 pi over 6 is a half, so is the sine of pi over 6. Now we're going to solve these equations for x. So we're going to multiply both these equations by 3 to solve for x. So we get x equals 3 times pi over 6, that'll reduce to pi over 2, plus 3 times 2 pi k is 6 pi k. Now we're going to take 3 times this, times x over 3 is just x. Then 3 times 5 is 15 pi over 6. You can cancel one of the factors of 3 here. So 6 can be written as 3 times 2. So we get 5 pi over 2 plus multiply 2 pi k by 3, and we get 6 pi k, where k will be an element of the set of integers. 3c. So it says the cosine of 2x equals the square root of 3 over 2 on the interval from 0 to 2 pi, including 0. So we only want to list the solutions that are in between or including 0 up to 2 pi. Now again, we recognize square root of 3 over 2. We are familiar with that x coordinate on the unit circle. So I'm saying x coordinate because cosine of an angle represents the x coordinates on the unit circle. So I'm going to draw the 2 points on the unit circle that have an x coordinate of rad 3 over 2. There's one right here, and another one right there. All right, looking back up the equation, cosine of 2x equals square root of 3 over 2. So we're figuring out what all of these angles have to be, what 2x has to equal. So 2x has to equal pi over 6 plus 2 pi k. So this equation only represents all of the angles in blue that are in the first quadrant. We just keep adding multiples of 2 pi, or if k is negative, we're subtracting multiples of 2 pi to go around and around the circle. All right, now then we have 2x equals 11 pi over 6 plus 2 pi k. So we have this equation here. We just figured out all the angles that will make this statement true, but then we have a 2x. We have to go and solve for x here. So we can divide each side of the equation by 2, which is the same thing as multiplying both sides by a half. So a half times 2x is 1x. 1/2 times pi over 6 is pi over 12. A half times 2 pi k is pi k. A half times 2x is going to be 1x. A half times 11 pi over 6 is 11 pi over 12 plus pi k. And k has to be an element of the set of integers. Now the directions want us to solve on the interval from 0 to 2 pi. So I'm just going to rewrite this equation real quick. This is pi over 12 plus 4/4 pi k. Whoops, I actually want to make that 12/12 pi k. What I had was true, but my goal is to combine these values here, and I need a common denominator. So pi k is the same thing as 12/12 pi k. Again, this pi k I'll change to 12/12 pi, same thing as 1 pi k. So if we plug in 0 for k, that's an integer, we get 0 times this value here to be 0 plus pi over 12. So pi over 12 is one of our solutions. If k is 1, we'd have pi over 12 plus 12/12 pi. So that's 13 pi over 12. If I plug in k equals 2, that means I'll be adding 2 pi to pi over 12, which is out of our bounds. The solutions have to be in between or including 0, but no bigger, can't even be equal to 2 pi, can't be any bigger than 2 pi. So if I were to plug in k equals 2, the next angle here would be 25 pi over 12. And 12 divides into 25 pi more than 2 pi times. So that cannot be a solution. Plug in 0 for k here, we get 11 pi over 12. Plug in 1 for k, we get 11 pi over 12 plus 12/12 pi is 23 pi over 12. That's really close to 2 pi. 12 almost divides into 23 2 times. Now, if I look from 0 here, boop, boop, to 2 pi, I see 2 angles, 1, 2. So looking at the equation, I think there's 2 answers times 2. I should be expecting 4 solutions to this problem. That's my expectation. And I see that right here. 1, 2, 3, 4. All right, 1D. This one again wants the solutions between 0 and 2 pi. So we have sine squared of x. That can be written like this: sine of x in parentheses squared equals 3/4. So you take the square root of both sides, you get sine of x equals plus and minus the square root of 3/4. That simplifies to plus and minus the square root of 3, so we're at 3. The square root of 4 is 2. Now, we're familiar with this value on the unit circle. If not, we'd have to take the arc sine of both sides. But we are familiar with this value. So I'm going to go ahead and graph the points on unit circle that have a y-coordinate. I'm saying y-coordinate because sine of x represents the y-coordinate unit circle of square root of 3/2. That's right here and right here. So if you didn't have the negative here, then you would have excluded these solutions in the third and fourth quadrant. Okay, so my y value should be rad 3/2. Technically, this should be a little bit steeper than that. So that would be here, here. Now in the previous problem, I wrote a general formula because this was 2x. And so I wanted to see all the solutions. And in order to see that, I needed to have that formula and then plug in k equals 0 and 1. Here, though, this is just sine of 1x. So I don't need to write a general formula. So our solutions, that angle in the first quadrant is pi/3. The sine of pi/3 is rad 3/2. And when you square it, you get that's equal to 3/4. 2 pi/3 would have the same outcome. Now 4 pi/3, it's slightly different. The sine of 4/3 pi would be negative square root of 3/2. But when you square it, you would get positive 3/4. And the same if you plug in 5 pi/3. So these are solutions in between 0 and 2 pi. All right, question 2. We have to evaluate these expressions here given this information. So for part A, I'm going to expand the sine of alpha minus beta using the angle addition formula. So it'll be sine of alpha times cosine of beta minus sine of beta times cosine of alpha. Now here, it says secant of alpha equals 3/2. That implies that the cosine of alpha equals 2/3 because the secant function and cosine functions are reciprocals of one another. Now check this out. It says alpha is in between 3 pi/2 and 2 pi. So when you draw this angle, alpha, you have to draw in the fourth quadrant. Now I'm not familiar with this angle that intersects the unit circle at 2/3. So I'm not going to draw a unit circle. I'm just going to draw a right triangle. When I say I'm not familiar with it, I know that alpha is not going to be an angle that's a multiple of pi/4 or pi/6. So the cosine of alpha, remember SOHCAHTOA, that's the adjacent over the hypotenuse. So we'll use the Pythagorean theorem. If we square 3, we get 9. You square 2, you get 4. 9 minus 2, well, 2 squared. So 9 minus 4 will be 5. So this side here is going to be negative square root of 5. We're going to the right, and then we're going down. That's why it's negative, because we're going down from the x-axis. So the sine of alpha, so knowing SOHCAHTOA is given a right triangle, sine of alpha is equal to the opposite over the hypotenuse. The cosine of alpha is equal to 2/3. All right, now let's graph the angle beta. It says here beta is in between 0 and pi over 2. So here's the angle 0 to pi over 2. Beta is somewhere in the first quadrant. I'm not familiar with an angle that has a slope of 3/4 tangent. I'm thinking slope of the angle. So the beta will not be a multiple. It won't be an angle. It's multiple of pi over 6 or pi over 4. So I'm just going to go ahead and draw a right triangle and use SOHCAHTOA. So tangent of beta is the opposite over the adjacent. And if you use the Pythagorean theorem, 4 squared, which is 16, plus 3 squared, that's 9. 16 plus 9 is 25. So the hypotenuse is equal to the square root of 25, which is 5. So the square root of 25 is 5. So the cosine of beta is the adjacent side over the hypotenuse. That's 4/5. The sine of beta is equal to 3/5. So we get negative 4 rad 5 minus 6 all over our common denominator of 15. So 3 times 5 is 15. This 5 times 3 is 15, so it's a common denominator. You cannot combine this numerator because those are not like terms. So that's going to be our final solution. Part B, we have the cosine of alpha minus beta. So knowing our formula, this expands to cosine alpha, cosine beta. Because this is a minus sign here, this will be a plus sine of alpha times sine of beta. Now, I'm just going to use the parts above here rather than look at the triangle. Here I have cosine of alpha is 2/3. I'm going to plug in 2/3 here. Cosine of beta, I could look back at the triangle, but I have the value right here. Cosine of beta is 4/5. Sine of alpha is negative rad 5 over 3. And the sine of beta is 3/5. So again, 3 times 5 is 15. 3 times 5 is 15. So these have a common denominator of 15. They always will. So I'm going to add these up. These fractions, our denominator will be 15. And we get 8 minus 3 times the square root of 5. These are not like terms. So we cannot combine those. And that's our final answer. Okay, question 3. So I want to solve this equation for x. And it's similar to the one that was on last week's quiz. Now, before I take base e, I would like to consolidate. I would like to condense these logarithms. So in the first step, I'm going to add the natural log of x plus 1 to both sides of the equation. So I added natural log of x plus 1 to both sides. Now I'm going to use the product rule to condense this. Now to solve this logarithm, the inverse of natural log of x is e to the x. So to undo the natural log, I'm going to take base e to the power of both sides. And so the left side will become x minus 3 times x plus 1, and the right side is e to the 4th. I'm going to go ahead and expand this. So that's x squared minus 2x minus 3 equals e to the 4th. Now, just like last week, I made this problem where this coefficient is going to be an even number. So I'm going to add 3 to both sides. And now I'm going to solve this by completing the square. Otherwise, you could use the quadratic formula. I'm going to add 1 to both sides. I get this number 1 by taking half of negative 2. Half of negative 2 is negative 1. When you square that, you get positive 1. So I add 1 to both sides. This equation will factor to x minus 1 times x minus 1, which is x minus 1 squared. The right side will simplify to e to the 4th plus 4. We'll take the square root of both sides. That's plus or minus the square root of e to the fourth plus 4. Add 1 to both sides. Now, we have two numbers here, 1 plus the square root and 1 minus. It's two numbers. And those are both solutions to the equation right here. But they're not solutions to these two steps, the original problem, because before you condense, the domain is saying here that x has to be bigger than 3. So an answer has to be bigger than 3. And if I have 1 minus the output of the square root, it's not going to be bigger than 3. So I have to get rid of that. And we only have one solution. All right, question 4. So the goal is to graph. What I'm going to do is I'm going to find the y-intercept first. I'm going to plug in 0 for x to find the y-intercept. So we plug in 0 for x, you get the cosine of negative pi. Take that value and times 2. So the cosine of negative pi is going to be negative 1 times this 2 is negative 2. So the y-intercept is negative 2. We should recognize that our amplitude is 2. So this 2 times cosine. So our max value is 2. Our min is negative 2, and that happens to be the y-intercept. Because the y-intercept is there, this graph has to be symmetric to the y-axis. The distance from the origin to this first x-intercept to the right of the y-axis is going to be the exact same distance from the left. This graph is symmetric to the y-axis. So some people have these two x-intercepts labeled differently, even though you have a graph symmetric to the y-axis. It has to be the same value. If I go up and down, starting from this blue point and going to the right, that's one period. The directions ask you to graph at least 2 periods. Okay. This x-intercept for cosine, when a graph is symmetric to the y-axis, it looks like the cosine function. And normally that's pi over 2. But if you divide by this 3, that input compression, this would become pi over 6. Now, what I could do is I could show you the period of this function is 2 pi divided by the coefficient of x. So it's 2 pi over 3. That's the period for cosine, sine, secant, and cosecant. It's 2 pi divided by the coefficient of x. Now, half the period, if I take half of this, I get pi over 3. Now, this is important to know because the x-intercepts are always half a period apart for a sine, cosine, secant, cosecant function, as long as you're not shifting the graph up or down. So from this pink point to this pink point, the total distance has to be pi over 3. So some of students will label this first x-intercept pi over 3, but that can't be. It has to be this entire distance from my fingertip. Fingertip is pi over 3. So since this graph is symmetric to the y-axis, this has to be half of pi over 3, which is pi over 6. If this graph, which it is symmetric to the y-axis, this has to be the opposite of that value right there. Now, again, from this x-intercept to this x-intercept has to be a distance of half the period, which is pi over 3. This total distance is 2 pi over 6. See, 1 6 pi is here, and then another 1 6 pi, that's 2 6 pi, which reduces to pi over 3. If I add pi over 3 to go from here to this next x-intercept, that's pi over 3 apart, I would get pi over 2. Let me do it this way. This pink point from 0 to here is pi over 6. There's another pi over 6, that's 2 pi over 6, 3 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces to pi over 2. And this has to be the opposite of that. Again, I know cosine, this looks like a cosine function with a reflection, like the parent graph. and this x-intercept is normally pi over 2. But if I divide by 3, it's pi over 6. This x-intercept is negative pi over 2 normally. Divide by 3, it's negative pi over 6. So I'm applying this horizontal compression that changed the period. It made it smaller. Instead of 2 pi, it became 2 pi over 3. It compressed the graph. This x-intercept for cosine of 1x is normally 3 pi over 2. But if you divide by 3, the 3's cancel, you get pi over 2. That's another way of looking at it. Okay, question 5. This answer cannot be 3 pi over 4. Why? Arc sine, you have to know that it outputs angles between or including negative pi over 2 to positive pi over 2. Here's what I'm saying. The arc sine of x has to always output an angle between or including negative pi over 2 to positive pi over 2. So the arc sine of this value will output an angle in this range here. So let's look at the angle 3 pi over 4. Here's the angle 3 pi over 4. This y-coordinate, this is sine, so I'm looking at this y-coordinate here, is rad 2 over 2. So if you wanted to, you could write this as arc sine of rad 2 over 2. And now right here in the first quadrant is another point that has that exact same y-coordinate. So the arc sine of rad 2 over 2 is going to be this angle in the first quadrant, because arc sine has to output an angle between or including negative pi over 2 to positive pi over 2. So this angle right here is pi over 4. Part B. We're taking the sine of this angle here. Arc cosine of negative 4/5, this part here will be an angle. Now, you have to know arc cosine outputs angles in between or including 0 to pi. So when I see arc cosine of negative 4/5, since the x-coordinate's negative, and knowing that the angle that arc cosine outputs has to be between 0 and pi, the angle must be in the second quadrant. I'm going to label this negative 4 and this positive 5. So arc cosine of negative 4/5, this outputs some angle. I'm going to call it theta. And so what I just did is cosine of theta has to equal negative 4/5. And so this is my reference angle here. This will be theta. Cosine of theta is negative 4/5. This missing side is going to be 3. We can use Pythagorean theorem to figure that out. If you square 5, you get 25. Square negative 4, you get 16. So 25 minus 16 is 9. The square root of 9 would give us this side here. This says sine of this angle theta, or sine of this angle here, is equal to the opposite over the hypotenuse. All right, question or part C. We have to recognize that this says cosine of an angle, cosine of another angle, and then here, this angle here is repeated there. Sine of the angle times sine of this angle. So this looks like it is the angle addition for cosine. So I'm going to rewrite this as cosine. I'm going to condense this as 7 pi over 12 plus pi over 12. This reduces to cosine of 8 pi over 12. 8 and 12 have a common factor of 4, so I'm going to reduce that, and that becomes 2 pi over 3. So if I draw the angle, 2 pi over 3, that's the angle there. The cosine of that angle is going to be negative 1/2. This coordinate on the unit circle is negative 1/2, comma, rad 3 over 2. Cosine is the x coordinate. All right, part D. Similar problem as what we had in, I think it was part A, where arc cosine, I wrote it down earlier, it has to output an angle in between including 0 to pi. So 7 pi over 6 cannot be our answer. That's bigger than pi. So if we think about the angle 7 pi over 6, that's right here. The cosine of this angle is going to be the x coordinate on the unit circle. That's negative square root of 3 over 2. Now there's another location on the unit circle that has an x coordinate of negative square root of 3 over 2. It's right here. So arc cosine will output this angle in red because that's in between 0 and pi. So from 0, this angle here in red is 5 pi over 6. Part E. We want to figure out the cosecant of this angle here. So let's pretend this angle is theta. So what we have here is tangent of this angle theta will output 3/4. Now arc tangent has to output an angle in between negative pi over 2 and positive pi over 2. And since this is positive 3/4, that angle has to be in the first quadrant. It's either the first or the fourth because of arc tangents, the possible outputs. 3/4 is a positive number, so the slope is going to be positive. We're going to draw a right triangle. So using SOHCAHTOA again, tangent of theta is the opposite over adjacent. The hypotenuse would be 5. 3 squared plus 4 squared equals 5 squared. Now, cosecant is the reciprocal of sine. So the sine of theta is equal to the opposite divided by the hypotenuse. So cosecant, we're going to take the reciprocal of 3/5 and we get 5/3. Okay, part F. Sine of pi over 12 times cosine of 11 pi over 12 minus cosine of pi over 12 times sine 11 pi over 12. I can see that's angle addition for sine, but that's a minus sign right there. And normally angle addition for sine has a plus. So it's going to be the sine of, and I have to subtract the two angles. I could change this to a plus sign here and make this sine of a negative 11 pi over 12 because sine is an odd function. So I could rewrite this as a plus and put sine of negative 11 pi over 12. In order to see that, you have to take pi over 12 minus 11 pi over 12. So part F, it'll condense because that's the angle addition, but there's a minus sign here. I'm taking pi over 12 minus 11 pi over 12. So those two angles simplify to negative 10 pi over 12. They being 10 and 12, they both have a common factor of 2. So I can rewrite this as negative 5 pi over 6. All right, 6, part A. So we want to simplify these expressions. The answer will be either a numerical value or a trig function. So we have to know that 1 plus tangent squared x is equal to secant squared x. So if I were to subtract 1 to both sides, we get tangent squared x equals secant squared x minus 1. So that secant squared x minus 1 is equivalent to tangent squared x divided by sine squared x. So secant squared x minus 1 is the same thing. It's equivalent to tangent squared x. I'm going to change the divide symbol to this symbol here by sine squared x. Tangent squared x is the same as sine squared x over cosine squared x times 1 over sine squared x. So when you're dividing by this term, it's equivalent to multiplying by the reciprocal. So I just basically flipped it, took the reciprocal. Now here, sine squared x will cancel, and we get 1 over cosine squared x. I'll take that for full credit, or you can rewrite this as secant squared x. All right, part B. So 1 minus cosine squared x. We should be familiar with this Pythagorean identity that sine squared x plus cosine squared x equals 1. If I subtract cosine squared x to both sides of the equation, we get 1 minus cosine squared x. So this is our Pythagorean identity. We're noticing that this is equal to that up there. So I'm going to take this problem. I'll just rewrite it. And using this information here, I'm going to replace 1 minus cosine squared x with sine squared x. And then cosecant squared x is the same thing as 1 over sine squared x, because cosecant squared x is the reciprocal of sine squared x. These will cancel, and the result will be 1. All right, last question, number 7. Okay, so we want to establish this identity. This is for sure is a true statement. We just want to show that it is true. So I'm going to take the left-hand side. And we have two options. Some people multiply by the conjugate, 1 plus cosine of x over 1 plus cosine of x. That works. Now what you could do is this. You could replace sine squared x with what we had in the previous problem. That's equivalent to 1 minus cosine squared x. Now here's the issue. Some students cancel terms. You can never cancel terms. So terms are separated by addition and subtraction. So you can't cancel the 1s or the cosine of x. What you need to show here is you need to factor. This is the difference of squares. That factors to conjugates. 1 minus cosine of x times 1 plus cosine of x over 1 minus cosine of x. So now, since we have times here, 1 minus cosine of x times 1 plus cosine of x, factors are separated by multiplication. So this entire 1 minus cosine of x is a factor that can cancel with that one there. Now we distribute this minus sign, we subtract, because our denominator now is actually 1. So 1 minus 1, that'll become 0. Then we subtract cosine of x is negative cosine of x, which equals the right hand side.